Hello everyone, welcome to Pratibha Tech. In this video, we will solve the problem of the day question on Geeks for Geeks for 24th February 2023. The problem statement for today is shortest path using at most one curved edge. This problem is based on graph and shortest path, and this has been asked in Uber interview question. So let's now open this problem. First, we will try to understand this problem statement clearly. Here it says, given an undirected connected graph of n vertices and list of m edges in a graph, and for each pair of vertices that are connected by an edge. Okay, there are two edges between them, one curved edge and one straight edge, and that is the tuple x, y, w1, w2 means the between vertices x, y, and there is a straight edge with weight w1 and a curved edge with weight w2. You are given two vertices a, b, so you have to go from a to b through the series of edges such that the entire path you can use at most one curved edge. Your task is to find the shortest path from a to b satisfying the above condition. If there is no path from a to b, then return -1. Okay, so here it is said that we are given a tuple with x, y, w1 and w2. That means for each tuple it is saying x and y are the vertices, so that means here it is 1 and 2 are the vertices, and there is a straight edge with weight w1 and a curved edge with weight w2. So here this is the straight edge weight and 4 is the curved edge weight. So if I see if you see in this diagram, then 1 and 2 it is talking about x and y 1 and 2. So here it is saying the straight edge is 1, but the curved edge weight is 4. Similarly, when we talk about this one 1 and 3, then straight edge weight is 2 and curved edge weight is 4. Between 1 and 4, straight edge is 3 and curved edge is 4. And between 2 to 4, a straight edge is 6 and curved edge weight is 5. So we have to go from A to B. A to B means A is equal to 2 and B is equal to 4. That means 2 to 4. We have to go from 2 to 4. So one option is to go through this way. It will take so here the cost will be 5. This way it will be 6. If we go from 2 to 1, so it will so here we have two options. One is to go through this straight edge, other option is to go through this curved edge. So here we will see if we are taking this straight edge, then from 1 to 4 we are coming at this one, we are coming through 3. From 1 to 4, if you are taking straight with this one, then it will be 3 and curved edge will be 1. So here we have to take at most one curved edge. So what we will do, we will take this straight edge and this curved edge, because this will give 1 plus 1 2. If you take any other option, suppose if you take this, it will be 4 and 1 5. If you are taking curved edge here, if you are taking this and this, then it will be 1 plus 3, it is 4. So the minimum will be this straight edge and this curved edge. So here you can say we can follow the path 2 to 1, 1 to 4. This gives the distance 1 plus 3 is equal to 4. If you follow all straight path, yes, so 1 plus 3 is equal to 4. But we can take the curved path 1 to 4, which cost 1. So the result of the cost will be 1 plus 1, 2. So we have to find that minimum cost to reach from node A to node B. Let's look at the second example. Here it is saying it consists of only two nodes there. We have to go from 1 to 2, and only one this matrix is given, and that means only one object is there. So from 1 to 2, what it was called? It was called a tuple. So only one tuple is given. From 1 to 2, the straight edge is 4 and curved edge is 1. So the minimum is here, obviously it is 1. So we will be using that way. So using so whatever we have discussed here, the approach here, so we will be using Dijkstra's algorithm to find the shortest path between the between the two nodes, that is from A to B, and after that we will see different options. That means when we are at any point, we will see that which path is more favorable for us. Is it the straight ones or is it the curved ones? But here we have to remember that we have to take only one curved edge. So let's start. I'll start coding, and while coding, I'll try to explain the how we are going through the code and the approach as well. So what we will do? See, here we can see we have been given in this shortest path function. It is taking the total number of node is n, total number of edges is m, starting node A and ending node B, and the edge represented as a list of edges, which is this one. So here what we will do, first we will create a list, that means a 3D kind of array list, which will be array list of array list of integers. So here we are creating the adjacency list that will store the value for the nodes. That means from the current node wherever we are, so the adjacency list to reach all of the nodes, that will be stored in this one. So let's give this name as graph, and here it will be graph, it will be type of new array list. Okay, here we'll be creating another list, array list, that is again we should type of int array, and this we'll call it as a curved, and this will be again a type of integer array list. Oh, sorry, both the places I've given capital. So here what we'll do, first of all we'll initialize the graph with a newly created the array list, that means empty array list. Okay, so what we'll do, it will go up to the number of nodes we have, that is equal to n, and it will be, sorry, here it will be increment by 1 I plus plus, and here we will do graph dot add new array list, so we are just initializing it, so that if we are performing any operation with this graph or this array list, so that time we do not get any null pointer there. So we have initialized it. So now what we will do, once this is done, then we will start our coding. Here this was just the initialization, but so now we will start with our edges here. That means what are the input or the tuple, whatever we have got, we'll start playing with that. So here it will be array list of integer, will give some name here as edge, and it will iterate over edges, edges, and here see, here we will extract each element. See, here we have seen that this tuple consists of 4 elements. So we'll just extract each of them, saying int u is equal to edge dot get 0, int v is equal to edge dot get 1. So here this u and v are the two edges there. Now whatever we will be fetching out of it, that will be weight 1. Weight 1 will be the straight edge, and that means the straight weight. That will be h dot get at index 2 whatever we have, and finally w2 here for the curved weight, and it will be index of 3. So for each for a tuple or for the edge which we are taking into consideration, we are taking this, and to this we will add so whatever we have got this. So from u to v whatever, what is the weight? W2. So we will simply add it to curved here, so that whenever we are performing the Dijkstra's algorithm, so that time we can take into consideration this this curved path. So what we can do, we can add curved, this is simple, this is array list. So curve dot add of new int array of what we have, three things here: u, v and w2. I hope this part is clear. So once we are done with this one, then we will try to add to the graph whatever the adjacency list which we will be creating, that we will be adding here. So for adding it to graph, that means we will be creating adjacency list of u and v, and that we will be adding. So for that we will create a placeholder variable that will be again of type array list of integer. Let's name it with t1 is equal to new array list and to this what we will add, since we are creating a adjacency list, so what we'll do, we'll add an edge and its weight. So to this t1 dot add, we'll add v t1 dot add w1. We are just we have already taken care for the curved ones, we are doing for the straight ones here. So similarly, once we are done with this, so we'll copy it for other v also. That means for v also we will create. So this one here, but this time here it will be, we will be adding u here, and we will be again adding here w1, because the state edge is between these two. So if you're taking 1 and 2, so either we take we create adjacency list here, so from 1 to 2 or 2 to 1, both places it will be this state edge weight will be 1 only. So that reason we just rename it with some other variable 2, sorry, here t2, okay, and here also so once we created these two array list, so what we can do now, graph dot get u, which will be empty here initially because we have just initialized it with a new array list. So to this one we will add t1 dot add t1, this array list whatever we have created, this one. For u, see, from u to v, this one will be the weight. So we are creating a adjacency list for u here, and we are adding t1 because t1 is holding from this location u to v with weight 1. Similarly we will do for v also. Sorry to not copy it, Control C. So here it will be from v to u, that will hold the data in t2, okay. So once this is done, then once we are populated with this one, that means an entire graph is populated. Then what we'll do here, we will try to find the shortest distance by calling Dijkstra's algorithm. And to this what will pass? We will pass A, we'll pass the number of nodes there, and we'll pass the graph. And to this it will return the shortest distance from A. So we'll try to store it in some variable calling DA, something like that. Copy it again, and we have to find from both sides, from A and B, so that's why we will be calling it twice. Okay, we have to reach from A to B, but yeah, we will find a minimum distance from both sides. So here it will be, instead of DA, it will be DB, and here instead of starting point as A, we will be pointing to B. Okay, so this we will be getting two answers here, and that means two minimum distance here. So we will be initializing it, that means the response type or the answer, the variable, okay, which we have to return with DA of anything, DA of any distance there, that will be here. Okay, we will be calling for this one. So see, this one is holding the value for distance from A, so we will be passing that B in this one, and we'll see, that means for each for that index B. Okay, so here after that what we'll do, we'll iterate over the curved thing, that means for, see now here through this one we have got the state distance. Now we will be even taking into consideration the curved edges. So what we'll do, from that, this int array, which is the holder for that is curved thing, so we will do edge, and we will iterate over the curved ones to add that curved distance to the above value, and we'll see from which one we are getting the minimum one. So I hope, see, this Dijkstra's algorithm, this will give the shortest path with using the straight lines between node A and B. And to this one, we will check whether that was the minimum, or when we add the curved ones, then we are getting the minimum one. So again, from that array, we will again extract some variables, that int u is equal to edge at 0, that whatever we had saved it here, that only we are initializing again. We had added it here, this one u, v and w2, so that we are trying to extract. So we are giving here the variable name as int u, then int v is equal to edge of 1, int weight is equal to edge of 2. Okay, so once we got this, then here we will find that what will be the answer. Here will be math, that which is the minimum one. So math dot min of whether the answer which was here, that was minimum, whatever we have initialized it with this one, whether that was minimum, or whatever we are getting when we are passing, when we are looking for u, that means for u index plus this curved weight, okay, this weight plus db of, now we are checking for the second from the second distance whatever we have got there. For that we will check for v. See, U and V are the vertices here. So when we are passing, when we are getting those three, so I'll explain in this Dijkstra algorithm what we are doing. So then it will be more clear that whatever we are passing here, so the whatever the response we are getting, so we will just check here whether this only was the initial one, that minimum one, or when we are starting with what is U and V, and we add the weight to it. So copy this, the second option we will also do. So control C, it will be control V. Here it will be from the second one, dB of U weight and dA of V. dA of V. Now this is getting closed here. So here we will simply check if answer is greater than equal to, see, if we are getting infinite there, then only we have to return 1, minus 1. So we will just check if it is greater than integer of 1 to the power e9, 1e9, then we have to return minus 1. Here this one 1e9 is 1 to the power, that means 10 to the power the 9 only, so we are considering very large number here. Else return this, and if it is not there, then we will simply return answer. So here what we have done in this method, just a minute. So what we have done is in this method, so we have created an adjacency list, of adjacency lists, that is called graph, and the empty edge curve, and if then we are looping against with these edges, and for each u, v, wn and w1, w2, that means these are the 4 parameters which we are getting from tuple, we are adding v with w1 in use adjacency list, and u and v1 to v adjacency list. It also add u, v and w2 to the curved. Then we are calling the Dijkstra's method twice, once with a as the starting node, this one, once a with the starting node and once b with the starting node, to get the sorted distance from a to b, from a and b to all other nodes in the graph. Then we are initializing answer to be the distance from a to b, which was just calculated. Then it iterates over all the elements of the curved. For each element u, v and weight, it calculates the distance from a to v through u, a to b through u, by adding dA of u, weight, and dB of v. It also calculates the distance from b to v, here, from b to v, by adding dB of u, weight, and dA of v. It takes the minimum of these two distances, and we are updating answer. And here we are saying that finally, if that answer is still greater than integer of, that means 1e9, it returns minus 1 to indicate there is no path between a to b. Otherwise it returns answer, which represents the shortest path between a and b in the graph, which potentially has the both straight and curved edges. Okay, so this part is done. So now for this Dijkstra's algorithm, to save the time, actually this answer is very long, so I've just typed it earlier, so I'll just paste it here, but I'll explain all these things whatever is happening in this method. So I'll just paste it below, and here we'll see this line by line, that this line defines a method Dijkstra that takes three arguments, that is node A and the number of node n, and graph represented as an array list of integers. The method returns the and this is returning that integer array. Okay, so first of all, this line whatever we have here, we are creating a new integer array of length n plus 1, which will hold the distance from starting node to each node in the graph. Okay, so here this line sets all the element of that array which we have created, that is dist, to a very large value. That means 1 to the power 1 EU to the power 9, which is 1 billion. Okay, this is done to simulate an infinity distance for all the nodes that have not been visited yet. Okay, I hope this much is clear. So here first we are setting this line sets the distance from starting node A to itself is 0. That means from 1 to 1 it will be 0. So after that we have this visited array here created. This line creates a boolean array of length n plus 1, which will keep track of whether the node has been visited during this iteration or not. That means during this algorithm or not. Then here we are creating a priority queue here. Priority queue that will be used to store the nodes that need to be visited during algorithm. The priority queue is initialized with a comparator that compares the distance of each node, so that the node with the shortest distance is always at the front of the queue. So out of these two, which one will be the shortest one? That will be in front of the queue. So after that, what we are doing, then we are adding the starting node A to the priority queue with the distance 0. Then we have this while loop here. This block of code, what it does, so here this block of code starts with while loop and continues until there are no more nodes to visit. Inside the loop, the node with the shortest distance is removed from the priority queue. We are removing it from the priority queue and assign it to variable u. The visited array is updated and indicate that you have been visited. This one. Once we are taking this out, then we are getting u and we are marking that u as visited. Then after that we have this for loop here. This block of code loops over all the neighbors of the current node u that has come out of this priority queue in the graph, which are stored as array list of two integers. First integer is the neighbor node's ID, and the second integer is the weight of the edge between you and neighbor. Okay, this one between you and the neighbor. So here then we have this one. Then we are checking that whether the neighbor node V has been visited, whether there is a path from the starting node to u, that is the distance of u is not infinity, and whether the distance from the starting node to V via u is shorter than current best known distance from the starting node to V. If these conditions are met, then the distance to V is updated and V is added to the priority queue with this new distance. We are adding this one to the priority queue with the new distance. Okay, and finally we are coming out to this while loop and return the distance array what was calculated during the algorithm. So for this only, whatever this array is holding, so that value which we are using here with u and v, and we are trying to get the distance from u to v and through all the nodes there. Okay, so I think so I'm done with my coding. Let's try compiling the code. So here we can see we have got our output correctly. So now let's try submitting the solution. So here we can see we have got our all test cases passed and we have solved this problem successfully. Yeah, so that's all in this video. Please like, comment and share the video, and please subscribe to the channel for more upcoming videos. Thank you for watching.